Okay, moving on to the next section of chapter 3 then. So simultaneous equations and graphs. So everything in the previous section, you could have drawn the graph of if you were so inclined. And if we drew both at the same time, the intersection of those would be our solution. That's the link to this part. So what is a line? What is y equals 2x plus 1? Well, graphically, everywhere along that line is a coordinate, okay? And all of these coordinates are sets of x and y values that satisfy a rule. So everywhere on this line is such that if you put the x and the y values in here, this equation will work. If it's not on the line, it means that that equation doesn't work, okay? Well, if I draw another one, so if everywhere here satisfies that rule and everywhere on this satisfies a different rule, well, the intersection in the middle does what? It satisfies both rules at the same time. And the rules are just equations. So in other words, it's the solution to that system of equations. And setting up systems of equations and solving them is where you can find out really, really useful things in maths. So let's look at some examples. So here we've got a straight line in ax plus b equals c form, and we've got a quadratic, and we've sketched them here. And you should just check that you should be able to sketch these as well. Well, the question is, use the graph to write down the solutions. If you ever hear the command use the graph, you must use the graph, okay? Please don't solve this algebraically, because that's not what the question is. So it's said for us to use the graph. Well, we're just reading off the values. So this is 2 minus 1 and minus 1, 5. Okay, make clear which x and y's belong together. What algebraic method could we have used to solve them both? Well, we could have just substituted the linear one into the quadratic one. That's what we could have done. Okay, and that would also have given us the same value. If we think about chapter 2, you learn about the discriminant a little bit. Something else you would have found is when you substituted them into each other and you made your quadratic, so slightly complex point coming up here, when you combine the equations together simultaneously, that actually creates its own quadratic. And so far you just solved that and you didn't think about it. But this quadratic that you form by putting the two systems together, you could actually do the discriminant on that part there. And what would that tell you? Well, that would tell you a little bit about the behavior of the solutions. So if you did the discriminant here, the discriminant is greater than 0, and hopefully it's been drummed into you by now, that if the discriminant is greater than 0, it means that there are 2 real solutions to this situation, which is correct. Okay, so we didn't even actually need the graph, you could argue, and once somebody gives us this equation here, without knowing anything else, we can just do the discriminant and we can say, oh, there are 2 solutions in this scenario because there are 2 roots to that new quadratic. So that's a slightly complex point, but we will come back to that. We'll practice that a bit more. Okay, so let's move on a little bit. Another example, so sketch these. We've got a linear and a quadratic. Notice that they don't intersect. So try and think about what I just said before. How could you prove that they never meet? How could you prove that there are no solutions in this situation? Well, the chapter is simultaneous equations, so we could try combining them together simultaneously, and it should generate another quadratic. And you can do the discriminant on that quadratic, and you will find it's negative. And what do we say if it's negative? It means that there are no solutions. So there's 3 things going on here. There's the original curve, the original line, combining them together to make a new curve that we don't need to draw. Okay, there's no need for us to draw that. And doing the discriminant on this new quadratic here. Okay, make sure it's set equal to 0, please. And if it's negative, it means they don't intersect. So how is that useful? It's useful because you know that the drawing, they wouldn't intersect each other without having to actually draw it yourself. Okay, so let's just summarize what we said. So we can combine simultaneous equations together to create a quadratic that's set equal to 0. If we do this, for the resulting quadratic that we make from this, okay, notice I say the resulting quadratic that we make from this, it's not the start, okay? We look at the discriminant and 3 cases. We looked at greater than 0. Greater than 0 meant that there were 2 real solutions, okay? It means that they intersect twice. We also just saw negative, that just means negative, okay? If it's negative, it means they don't intersect at all. And then in the middle, there is the case where it's equal to 0. Where it's equal to 0, you will have one real solution, or you can kind of think of this a bit like a repeated root. This is used for tangents, okay? Exam questions love this one for a star. Yeah, they won't make it explicit, but if you think about the situation and there's a tangent going on, or 2 lines just touch once, chances are you're probably looking at this kind of scenario. I'll just show you an example. So here I've got a quadratic and a line, and I've sketched them each, and I've chosen them such that there's just 1 point. So what happens? Well, what should happen is if you combine these together and then you do the discriminant, you should get 0. And you don't need to do this, but just in case you're interested, I've actually drawn what it looks like, the new quadratic. And look, the new quadratic has just that one root, it just touches. So that's another way you can think of it if you prefer. Let's do a work example now then, so something a little bit wordier. No, we don't need that one there. Let's just annotate. So the line with equation y equals 2x plus 1, so there's a straight line. Let's just sort of draw it. So there's a line that looks like that. Let's call that L1. So L1 looks like that. It meets the curve with equation, okay, x squared plus 2y plus k minus 2 equals 0. So you see the problem here is I can't really draw that. I don't know what it looks like. But it meets this curve at exactly 1 point. So something I might just do, just to help me think about it, is I might draw something on conceptually to help me think about what I'm doing. I'm not saying this is accurate at all. This is just to help me think about what I'm doing. So they meet at exactly 1 point. So L1 and L2 meet at 1 point. That is a key piece of information. Given that k is a positive constant, don't worry about this too much yet. It just means when we find out what k is later, we want to check that we do that thing there. It might be helpful. Find k. Okay, so let's start with what we know. So all we know is that they touch at 1 point. So that means if I do 2x plus 1 and kx squared plus 2y plus k minus 2 equals 0, if I try to solve them simultaneously, the discriminant of the resulting equation should be equal to 0. Yes, you are expected to know that just from the word prompt there, okay? I'm going to go straight in with substituting that in. So y equals, so let's keep the kx squared the same, plus 2 bracket, plus k minus 2 equals 0. And this part here needs to go there. So 2x plus 1. So kx squared plus, let's change the pen again, 4x plus 2 plus, the brackets aren't really doing anything there, so I'm just going to put plus k. Let's go plus k minus 2 equals 0. We'll clean this one up a little bit, so collect like terms together. So kx squared plus 4x. Now, 2 minus 2 cancels. K, what is k? K is just a constant. So that's like the c bit. If you think ax squared plus bx plus c, that's the c part. Plus k, and then always equal to 0 to solve. So this is my new equation. Have I used the fact that they touch at one point yet? No. So this thing here means that b squared minus 4ac should be equal to 0. So here's what you do. You underline each part. A is k. B is positive 4. C is positive k. Okay? And now we substitute them into this one here. So b squared is 16. Just because my space is limited, I'm going to do a little bit lighter on the working out. I'd like you to put a bit more in there, so it's clearly substituted. So b squared is going to be 16 minus 4 times k. So 4ac, 4 times k times k. So minus 4k squared equals 0. And look at that. We now have an equation that can actually be solved. Okay. What could k be? Well, you can divide by 4, so 4 minus k squared. So k equals plus or minus 2. But a must be a positive constant. Okay, so we need to disqualify this value and say that k is equal to 2. So look at that. We cannot know x or y or k, and we can solve this because we combine them by eliminating y first of all, and then we use the fact that we've got the discriminant. So find the value of k. We have done that one there. For this, use the k to find the x. Well, you know that this happens when k equals 2. So now what you would do is you just put k equals 2 back into your y and back into your x. I'm going to just clear the board so you can see a neater version. Okay. Right, have a go now then for yourself. So this is all about using the discriminant. There's the equation, 2 distinct real solutions. That's a signal that you need to understand. You need to know exactly what that means. It's got something to do with the discriminant. And the first part is show this equation here, and the inequality sign is important, okay? It must be accurate. So pause the video and have a quick go at part A. So for part A, they want to see that you're using b squared minus 4ac is greater than 0, clearly substituted in, and then manipulated. Okay, there's no pulling the wool over the examiner's eyes. Yeah, you need to show that. It needs to be beyond doubt, it's clearly substituted. That's a very common area for students to drop marks. So this equation about k is true. That's what you're solving in here. And then it says, hence find the possible set of values. So why does it say set of values? Well, it says set of values because you're dealing with an inequality. Yeah, we said this at the start of 3A. It sometimes has a set of values. Here's what you need to do for part B. You need to sketch this. Do not resist needing to sketch it. You need to sketch this. So many students try not to do this and they lose marks. So it's really stupid. Okay. First of all, let's sketch this, and I want you to just think of the k's like an x. So if I said to you, x squared minus 5k plus 4, what would you do? Well, probably you try factorizing it. So you can factorize this one here. If you factorize, you're going to get, with k instead of x, you're going to get minus 1 minus 4. And then you can draw it, can't you? You know it's a positive quadratic, so it's got a shape like this. You know what the roots of that quadratic there are, so you can draw it. So 1 and 4, that's what the graph for k looks like. Now, where is the graph greater than 0? It's greater than 0 over here and over here. Okay, if you sketch it, you will see this really, really easily. It doesn't have to be a great sketch. It just has to be something quick to help you think about it. So when k is over here And when k is over here, this works. And that's the final piece, okay? Find the set of possible values. So we will say that k can be less than 1, or it can be greater than 4. That's what we're looking for. Okay, so we're looking for this one here. Bonus points if you can write it with set notation. So very occasionally, the exam paper wants you to write it with set notation. So you're going to do something like this. So rule for k is that k is less than 1, or k is greater than 4. Okay, no one can argue with you if you do something like that. And that takes you up to exercise 3C. So please spend a bit of time on this. 3C is its own lesson because the discriminant is a hugely important concept. Best of luck.